Hi, this is KRISTEN Martinez, and I'm in Math 1073 at UTSA, Mr. Fies class. I'm doing Newton's Law of Cooling, and this is the problem that I created. Jimmy comes back home from UTSA for spring break to find that his pet rat, Joey, died sometime between yesterday and this morning due to lack of food and attention by Jimmy's family. When Jimmy came home at 2 p.m., the body of his rat was approximately 90 degrees Fahrenheit, and at 4 p.m., the body cooled down to 85 degrees. If Jimmy's dad never changed the thermostat temperature, and nobody entered Jimmy's room except for Jimmy himself when he came back home to see Joey, his room stayed at a constant temperature of 80 degrees Fahrenheit. Approximately at what time did Joey die? Okay, in order to figure this problem out, we have to set up Newton's Law of Cooling right there, where this is the current temperature, this is the temperature of the room, TO is the temperature of object, which would be his rat, and then the TA would be the temperature of the room, which is 80 degrees. And then we have E, and then our constant and our time. And our constant K is our decay coefficient. So first off, we're going to mark it down as all of the temperatures. So it's going to be 85 degrees is what time Jimmy found his rat. That's the temperature. And then it's going to equal out to 80 degrees for the temperature of the room. And then it's going to go to plus, and then you're going to multiply the temperature of when he first found his rat. This was at 2 hours. This is when 2 hours has passed. And this is when he first found his rat. And then this is the temperature of the room. This is very important right here because you need to add it to the 10 degrees that this equates to, because it helps to figure out at what time Jimmy's rat, Joey, had died. And then you're going to multiply it by E, natural log of E, and then that's going to be to the power of our decay coefficient, which is going to be a negative number, and then T, which is time, and it's going to be 2 hours. And then you're going to take away the 80 to even it out, which leaves us with 5 on one side, and that's going to leave us with 10. 90 minus 80 equals 10. And then you're going to multiply that by our natural log and our decay coefficient, and then 2 hours. That is going to give us half on this side when you divide it by 10, and then it's going to leave you with E negative K to the 2. And then to take away the E, you're going to have to do the natural log of half, and then you're going to have to put natural log with the E, and that's going to cross out to where it brings down negative K2, so that you can actually start solving it now. So natural log half divided by 2 time, it's going to give you negative 3.4657. That is K. That is our decay coefficient. Which then brings us to step 2 of this problem, of what time Joey died. So that's the difference in time. Difference in time right there. Then it's going to be negative 2 over our decay coefficient, 0.34657, multiplied by natural log of what temperature his rat was when he initially found him, minus the temperature of the room, over the temperature his rat originally was when he was alive. Let's say it was 95 degrees when he was alive, when Jimmy's rat was alive. And you're gonna divide, you're gonna subtract that by the temperature of the room again. And all of that multiplies out to where it's going to end up equaling 2.3399 hours. So if his rat died at 2 p.m. and then 2.33 equates to about 2 hours and 20 minutes, Jimmy's rat approximately died at about 11:40 in the morning. Thank you.